Okay, so this video is going to be on conditional probability. And conditional probability, you have two events, say the probability of A, and then this line here means given B. So this is the probability of A given that B happened. And basically, conditional probability, what you're doing is you're reducing the sample space. Okay, so the probability of A given B is the probability of A and B over the probability of B. Okay, so it's the probability of what they have in common over the probability, and this denominator, it's always going to be the probability of that second number. Okay, another way that you can look at it, the probability of A given B is if you write it out, if you write out the events in sets, you can say the number of elements in A and B over the number of elements in B. Okay, so you can either do it as probabilities or you can count the elements in each set. So let's look at some problems. Let's look at problem 1. We have a single fair die is rolled. Find the probability of rolling the given event. So the probability of rolling a 4 given that the number rolled was even. Okay, so we have two events here. So I'm going to let event E be that it was a 4, and event F that it was even. Okay, so what I'm going to do is I'm going to write out these events. So E would just contain 4. That's, we roll a 4. F is it was even. Alright, so when we roll a die, we can get either a 1, a 2, a 3, a 4, a 5, or a 6. This would actually be the sample space of rolling a die. Okay, but the event F is just an even number. So that means we roll a 2, a 4, or a 6. Okay, so what we have here is the probability of rolling a 4, which that event is E, given it was even. And F means it was even. So if we write this out, well, that's the number of elements in E and F divided by the number of elements in F. So how many elements are in E and F? Well, E intersect F, well, it's what they have in common. Well, they both have a 4. So that's the only element they have in common. So how many elements are in this set? 1, divided by the number of elements in F, which is 1, 2, 3. And so our probability is 1/3. Alright, let's look at the next one. The probability we roll a 4 given the number rolled was odd. Okay, so let's look at this. I'm going to let the event that we roll a 4 is going to be represented by E, and an odd number is going to be the set F. Okay, so the set E is going to just consist of the number 4. The set F is going to consist of the odd numbers 1, 1, 3, and 5. Okay, and so the probability of E given F is equal to the number of elements in E and F over the number of elements in F. Okay, so we need E and F, or E intersect F. Alright, so what elements do they have in common? Well, they have nothing in common. So there's no elements in that. So this would be the empty set. They have nothing in common. So the probability would be the number of elements in this, which is 0, over 1, 2, 3, the number of elements in F. And so this would be 0. Okay? And which makes sense. I mean, it's telling us that the number rolled was odd, and they want to know the probability it was 4. Well, if it was an odd number, there's no way it could be a 4. Alright, what about this? Probability we get an even number given that the number rolled was 6. Okay, so the even number, that's going to be E. 6 is going to be F. So E consists of 2, 4, and 6. That's even number. F is going to be just the number 6. Okay, and so the probability of E given F is the number in E and F over the number in F. Okay, well, let's get E and F. Well, what do they have in common? The 6. So that consists of 6. And so the number of elements in E and F is 1 over the number of elements in F is 1. And so the probability is 1. Okay. All right. So let's look at another problem. All right. This time we have, if 2 fair dice are rolled, find the probability of rolling the given event. A sum of 4, given that the sum was less than 6. All right. So what we have to do here is we need to write out the sample space for 2 dice. If you've watched my other probability videos, I've done that before already. So I'm going to come down here and do it. So we've got 1, 2, 3, 4, 5, 6. That's 1 die. And then I've got a 1, 2, 3, 4, 5, 6. That's another die. Let's make a little table here. Okay, so if I roll a 1 and a 1, a 1 and a 2, a 1 on one die and a 2 on the other, and that's 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and then a 2 and a 1. Okay, so I'm going to pause it and finish out the table. Hopefully you can see the pattern. Alright, so here's our sample space. Okay, so let's go back up here and see what we've got. The probability of a sum of 4 given that the sum was less than 6. So I'm going to let this represent the set E, and the sum less than 6 represent F. Okay, so I need the probability of E given the probability we get a 4 given the sum was a 6. So that's the number in E and F over the number in F. All right. So E is a sum of 4. So let's see where that is. A sum of 4. That would be right here. That's a sum of 4. Okay. Now we need sum was less than 6. That's F. So where is the sum less than 6? Well, all of these equal 6. These are less than everything from here back. So that's all of that. Okay. So I need the probability of E and F. So that's what they have in common. So how many do they have in common? 1, 2, 3. Okay. So 3, 1, 2, 2, and 1, 3 is all in here. And in this one, it's in E and F. So there's 3 in there over how many's in F? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we get 3/10. Okay, let's look at the next one. A sum of 8 given that the roll was a double. Okay, so I'm going to let the sum of 8 be E, and the roll was a double, F. A double means like a 1, 1, 2, 2, 3, 3, and so on. Okay, so let's see, let me erase this. Okay, so the probability of E, a sum of 8, given a double. So that's the number in E and F over the number in F. Okay, so let's see, a sum of 8. Okay, let's circle that. Where's a sum of 8? That would be all of these. And then F, it's a double. So let's see. Here's a double. Okay. All right, so I need the number in E and F, the one that's in both of them, both E and F. Well, there's only one that's in both of them. See, the 4, 4 is in the blue, which represents F, and 4, 4 is in the green, which represents E. So there's only one element in that. So that's 1 over the number in F. F is the blue. 1, 2, 3, 4, 5, 6. And so our probability is 1/6. All right, let's look at this one. A double given that the sum was 11. So I'm going to let E represent it was a double, and the sum was 11 is going to be represented by F. And I need the probability of E given F, which is the number in E and F over the number in F. Okay, so let's erase this. Okay. All right, so the first one, a double, which is E, So here's a double. Okay. And the sum was 11. So where is the sum of 11? That is here. Okay. All right. So I need E and F. So what do they have in common? Well, they have nothing in common. You see that? They have nothing in common. So that would be 0 over, and then the number in F is 1, 2, a sum of 11. And so this probability is 0. All right, let's take a look at some more. All right, so it says if two cards are drawn at random from a well-shuffled 52 card deck, find the probabilities. The second card is a spade given the first is a spade. All right, so we want the, and so let's let this, well, let's do it like this. The first is a spade given, I'm sorry, we want the probability that the second is a spade given the first is a spade. Okay, so this one we can look at a little bit different. We're wanting to find the probability that the second card is a spade. That's what we're looking for. But it's telling us that the first card was a spade. Okay, and we're not putting the card back in after we draw it. All right. Well, what's the probability that the second card's a spade? Well, if the first card is a spade, we know that there's 13 spades in a deck. And if that first card was a spade, then that means when we draw that second card, there's only 12 spades. Okay? And since that first card's out, how many cards are left in the deck? 51. Okay? And so here's our probability. And you can punch that into your calculator if you want to. That's fine. Okay. Let's look at this one. The probability the second is a red given the first is a diamond. So we want the probability that we get a red given the first card was a diamond. Okay, this is the second is a red given the first is a diamond. All right, well, let's think about it. Okay, well, the diamond is a red card, and we took that out on the first one. The first card was a diamond. So that means there's how many red cards left? Well, there's 26 red cards in a deck. So if the first one was a diamond, which is red, then that means there's only 25 red cards left. And that's over. And then since that one card, that diamond's out, instead of 52 cards left in the deck, there's only 51 left. And so this would be our probability. Okay. And let's take a look at one more. Alright, so two fair coins are tossed, and it is known that at least one was a tail. Find the probability that both were tails. Okay, so two fair coins are tossed, and it is known that at least one was a tail. So this at least one was a tail, we're going to let that be event E, and find the probability that both were tails. Well, both of them are tails. We're going to let that be event F. So we want the probability that both were tails given that at least one was tails. See, because it says it is known that at least one was a tail. So it's the probability that both are tails given at least one was a tail. Okay, so that's the number in F and E over the number in E. Okay, well, let's write these out. Well, when we flip two coins, well, the sample space for two coins is heads, heads, tails, heads, heads, tails, tails, tails. Okay, well, what would E be? E would be at least one was a tail. Well, that's these three. And then F is both are tails. Well, what would that be? Well, both are tails is just this one. Okay, and E and F, or since we wrote it like this, F and E. Well, what do these two sets have in common? Well, the tails and tails. Okay, so the probability would be the number in F and E, which is 1, over however many's in E. 1, 2, 3. And there's your answer. Probability is 1/3. Okay, so I hope this video helped. Don't forget to like and subscribe, and check out the other videos I did on probability. I'll have all of these in the statistics playlist. You can check that out. And thanks for watching.